Hi there, I'm Graham Lewis, and in this short video I'm going to prove that when you have x to the power n and you find the first derivative, you get nx to the n minus 1. So here goes. Now, as we know, if the limit exists, the derivative of a function is the limit of h tends towards 0 of f of x plus h minus f of x over h. If you're not sure where that comes from, you might want to do some research on that first. So I'm going to assume that you understand that. So now let's go ahead and do this for the function x to the power n. So what I need to do is put x to the power n. I need to work out f of x plus h. So that would be x plus h to the power n minus x to the power n, because that's f of x over h. So I need to find this limit, which does exist, and then that will be the derivative of x to the power n. So when I'm expanding x plus h to the power n, I'm going to use the binomial theorem, but I'm going to use the nr notation rather than the n choose r notation. I'm going to use the nr notation because it's valid for fractions values of n and also negative values of n, whereas n choose r is only valid for non-negative integers like 1, 2, 3, 4, 5, 6, and also 0. Okay, so here we go. The limit of h tends towards 0, and the first term would be x to the power n. The second term would have coefficient n1, which is going to be n, x to the power n minus 1, and introduce an h. The third term is going to be n2, the coefficient, and x to the n minus 2, h squared, and so on. I'm going to put plus dot 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 minus the x to the n, all divided by the h. Now, good mathematicians always think ahead, so I'm just going to make this a bit smaller here. So when I'm thinking ahead now, if you look at this, it's really quite interesting, because what's going to happen is the x to the power n and the x to the power n is going to cancel. As soon as I've cancelled that, I can now cancel all of the h's. This h will actually cancel with that h. This h squared will cancel with the h, leaving me with an h. The next term, which would have been here, would have had an h cubed in it. H cubed divided by h would be an h squared. So every single term in the dot 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 will have an h to the power of 3 or 4 or 5 in it. And of course, as we limit h tends towards 0, they're all going to go towards 0. So that's the beauty of this proof. So let's do it. So limit of h tends towards 0, and here n1 is an n, x to the n minus 1, the h cancels, plus the next one would be n2, that would be n minus 1 over 2 factorial, which is 2, times x to the n minus 2, and that's going to have an h in it, because h squared divided by h is h. The next term will have an h squared in it. The next term will have an h cubed in it. When I limit h tends towards 0, they will all go to 0. That's why I'm writing plus dot dot dot, and I'm not worried about them. So now let's do the limit of h tends towards 0. Well, nx to the n minus 1 does not depend on h. So in other words, if we limit h tends towards 0, it stays the same. It is nx to the n minus 1. Now this term here, when I approach 0, is going to approach 0. So it's going to be a 0. The next term, remember, would have an h squared in it. That would be 0. So it doesn't matter. They're all going to be 0. All 0. And that's why we get the result that the derivative of x to the power n, if f of x is x to the power n, the derivative f dash of x or f prime of x is nx to the n minus 1, and we have our rule. Thank you very much for watching. If you enjoyed this video, please leave any comments or suggestions, and also I've made a longer video and explained the nr notation, the n choose r, and the binomial theorem, so if you want to watch those videos, they may help as well. Thank you very much. Have a great day.